Good day, viewers. Welcome back to Manual Statistics Arena. My name is Prince Andy, and I'll be your tutor for today's lesson. Today, we'll be looking at the Poisson distribution. The Poisson distribution is a discrete probability distribution that is used to find the number of times an event can occur within a given interval of time, space, volume, or area. For example, the Poisson distribution can be used to find the number of times the number of cases that has been recorded of a disease in a particular town. Or the Poisson distribution can be used to find the number of times a student goes for lectures in a day. It can also be used to find the number of times births occur per hour at a given hospital. Let's quickly look at the formula for a Poisson distribution. For any random variable, the formula for a Poisson is given as mu exponent x multiplied by e exponent minus mu all over x factorial. Or for any random variable x, the formula for Poisson is given as lambda exponent x multiplied by e exponent minus lambda all over x factorial, where x ranges from 0, 1, 2, 3, and so on. So the formulas are the same. It's just this variable that's changed among them. So for any Poisson distribution, you can either use the mu or the lambda. They are all the same. It's a variable. So you can decide to use the mu or the lambda when writing the formula for a Poisson. For the purpose of this discussion, we'll be using the mu. The mu or the lambda is the mean number of times an event can occur per a given interval. And our E is a constant whose value is 2.7183. Our X is the number of events in a given interval. for any Poisson distribution, the expected value is the same as the mean. So we have our expected value, which is the same as the mean, which in this case is either the lambda or the mu. And then for any Poisson distribution, the variance of the distribution is the same as our mu, or the mean. And then the standard deviation for any Poisson distribution is the square root of the variance. So we have our expected value, which is the same as our mean, our variance, which also equals our mean, and then the standard deviation, which equals the square root of the variance. So for any Poisson distribution, the expected value or the variance or our mean is the value for mu or lambda. For any Poisson question, the value that is given for, or the value that is assigned to the expected value, or the value of the variance, is what we use as our mu or lambda. In most cases, whenever you are given a Poisson question, the value for the mean is always given. But when the mean is not given in a question, we use the expected value. That is, if the question provides the expected value, we use the expected value. Or we use our variance. Since the variance and the expected value both equals our mean, which is our mu. And the mean, as we all know, is the same as average. Now let's quickly look at some examples under the Poisson distribution. So this is our first question. If the mean number of times a student goes for lectures in a day is 2, find the probability that in a day a student will go for 3 lectures. Let's quickly identify our variables from the question. We have our mean number of times as 2. So mu is 2 and our x is 3. X equals 3. The probability that a student goes for 3 lectures in a day first of all, the formula for Poisson is given as our mu exponent our x multiplied by our e exponent minus mu over x factorial. So probability of x equals 3 is given as our mu, which is 2, exponent x, which is 3, multiplied by our constant exponent minus mu all over our x, which is 3 factorial. And this is giving us zero point 180 0.1804. So that is our answer for the first question. 0.1804. So on the calculator, to enter your E, look at the bottom of the calculator. The third bottom, counting from your left to your right. On top of the third bottom, we have the E there. So to get this E, you press your alpha and then you press that particular button and then it gives you the E. So this is what we have for the first question. We had our x to be 2, our x to be 3, and our mu to be 2. Then we substituted these values into the formula and then it gives us this as our answer. Now let's look at another question. If the mean number of times a student goes for lectures in a day is 2, find the probability that in a day a student will go for at least 3 lectures. At least 3 lectures. So once again, we write down our variables. We have our mu as 2, and then we have our x as so the question says at least 3 lectures, which means our x is greater than or equal to 3. For that reason, our x is 3, 4, 5, and so on. This means to solve for this, we would have to find the probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5, and so on. It has an infinite number of values, and since that would be a hectic task to perform, we would rather find the opposite of this event. And to do that, we'll find the opposite of this event and subtract it from 1 to give us the answer for this. So what I'm trying to say is that we are to find the probability that a student will go for at least 3 lectures. If a student goes for at least 3 lectures in a day, it means a student goes for 3 or more lectures. And the opposite of this event will be less than 3 lectures. So instead of finding the probability that a student will go for at least 3 lectures in a day, we will rather find the probability that a student will go for less than 3 lectures in a day. Then we'll subtract it from 1 to give us the answer for our at least 3 lectures. This means we are going to find the probability that x equals 0, 1, and 2. Since the number of events less than 3 are 0, 1, and 2. So let's quickly look at the probability of x equals 0, x equals 1, and then x equals 2. So we have our first, once again, the formula for Poisson is giving us our mu exponent x. Our mu exponent x multiplied by our constant exponent minus mu all over our x factorial. Now, we are going to solve for these 3 values of x. So, P of x equals 0, 1, and 2. Because we first do for 0. So, we have our 0. We have our mu, which is 2. Exponent our x, which is 0. Multiplied by our constant exponent minus mu, which is 2, all over our x factorial. X in this case is 0. Plus, we now do for 1. So our mu once again, which is 2 exponent 1 times our constant exponent minus mu over our x factorial. X in this case is 1. Then we have our last value, which is the 2. So we go again. Mu, which is 2, exponent our x, which is 2, multiplied by our constant exponent minus mu all over our x factorial. X in this case is 2. So you have this for our 0, this for our 1, and this for 2. Now let's quickly find the values of the 3 using our calculators. So we have here we have our first value as 0.1353. That is the probability of x equals 0. The value for x equals 0 is 0.1353. So we have our 0.1353 plus the second. Probability of x equals 1. We have 0.2706. And then our third, probability of x equals 2. This one to 4 decimal places gives us 0.2707, and then probability of x equals 2, which is our third, also gives us 0.2707. Now adding the 3 values, 0.1353 plus 0.2707 and then another 0.2707. We have 0.6767. 0.6767. So that is what we get for summing the 3 events. But initially, what we said was that to find the probability of this event, we'll have to solve for its opposite and then subtract from 1. Now we've solved for its opposite, so we are now going to subtract from 1. So we have 1 minus 0.6767, and that gives us 0.3233. So the probability that a student will go for at least 3 lectures in a day, if the mean number of times a student goes for lectures in a day is 2, is given as 0.3233. So that is how you go about at most questions for Poisson. Whenever you get a Poisson question, and then the question is asking you to find the number of times an event can occur from a given number of x upwards, we always use this procedure in finding the value. Since with Poisson there is no limit to an x value, Poisson has an infinite number of x values. So for that reason, anytime we get a question that is asking us to find at least or more than, then we use this procedure. We find the opposite of that event, we subtract from 1, and then that gives us our answer for the at least question or more than. So for example, if this question had said more than 3 lectures in a day, is the same as at least 3 lectures in a day. So that is it for at least and more than questions. Now let's take another example. If the mean number of times a student goes for lectures in a day is 2, find the probability that in a day a student will go for. Let's clean something in the question and rewrite it. So if the mean number of times a student goes for lectures in a day is 2, find the probability that a student will go for at most 3 lectures in 2 days. Find the probability that a student will go for at most 3 lectures in 2 days. Now let's quickly look at something. The interval for a day, the interval of lectures or the number of lectures for a day is 2. But if you read the latter part of the question, it demands we find the probability that a student will go for at most 3 lectures in 2 days. The interval has now changed. Initially, what we had was a day. Now the interval has changed to 2 days. And with Poisson distribution, whenever you have a Poisson question whose interval change, then our value of mu has to change. Our average or mu will also change. So the average is only constant for a given interval. It changes per intervals. For a given interval, the average remains the same. But whenever the interval changes, the average will also have to change. So let's quickly look at the variables from the question. We have our mu for a day given as 2. But since the interval has now changed to 2 days, we'll multiply this value by 2 to give us the new value for our mu. So our mu is now given as 2 by 2, which is 4. And then our x is at most 3. At most 3 here means the highest value of x should be 3. So if the highest value of x should be 3, then we have our x to be 0, 1, 2, and 3. So probability of x being less than or equal to 3 is the same as at most 3. Being less than or equal to 3 is giving us x equals 0, 1, 2, and 3. So for at most questions, we don't need to subtract from 1. Since that one, our x values are finite, so we can solve for all of them. Since they are finite, we know the number of x values over here and we can solve for all. So for that, there will be no need to subtract from 1. So let's quickly substitute these values of x into the Poisson formula and let's see what we have. Our mu equals 4, and then our x equals 0, 1, 2, and 3. So once again, the formula for Poisson is giving us mu exponent x multiplied by our constant exponent minus mu all over x factorial. So substituting these values of x into the formula, we have probability of x being less than or equal to 3 equals, we begin with our 0, x equals 0, so we have this here mu exponent x multiplied by e exponent minus mu over x factorial. So we have our mu, which is 4, exponent our x, which is 0, multiplied by our constant exponent minus mu, which is 4, all over our x factorial. X in this case is 0, plus our mu once again, which is 4, value of x 1, multiplied by our constant e exponent minus mu, all over our value of x 1 factorial, plus our mu once again 4, x value 2, multiplied by our e exponent minus 4, all over x value 2 factorial. Then the final value of x, we have our mu once again 4, x value 3, multiplied by our constant exponent minus mu, all over the factorial of our x value, which is 3 factorial. So add all these 4 events and then look at what we have. For the first event, which is x equals 0, we have 0.0183, and then we have 0.0733 for our second event, which is x equals 1. And then our third event, we have 0.1465, which is x equals 2. And then our last event, we have 0.1954, which is x equals 3. So we now sum the 4 events. So we have 0.0183 plus 0.0733 plus 0.1465 plus 0.1954. So our final answer is 0.4335. So the probability that a student goes for at most 3 lectures in a day is given as, or is 0.4335. So that's what we have for this question as well. So we'll now let's take another example. Let's take another example. We are taking our final example under Poisson. if the probability that an individual suffers an adverse reaction from a particular drug is known to be 0.001, determine the probability that out of 2,000 individuals, more than 2 individuals will suffer an adverse reaction. Let's quickly look at how to go about this question. Reading this question, you realize there was no mention of an average or a mean inside the question. There was no expected value, there is no variance or standard deviation. But a figure was given, and then a number of individuals was given as well. But we have our x value. The question wants us to determine the probability that more than 2 individuals will suffer an adverse reaction. So from this, we have our x to be more than 2, which is x greater than 2. So our x is greater than 2. So what it means is that we begin from the next figure or the next value, which is 3. X greater than 2 means we have our x to be 3, 4, 5, and so on. But then we still don't know our value of mu. But from the question, we have a figure over here. This figure is our p, the probability that an individual suffers an adverse reaction. This is that probability. So that is our p. So you have p to be 0.001. And then the total number of individuals of which the question focused on has also been given, which is our n. So you have n to be 2,000. Now, to find the average or the mean, we multiply the n by the p. So the mu is given as np. So we have our 2,000 multiplied by 0.001. And that gives us 2. So we have 2 as our mu. So anytime a Poisson distribution does not provide the values of the average or the mean, the expected value, the standard deviation or variance, but provides the sample size and then the probability of a particular event, then we find the mu by multiplying our sample size, our n, by our p, and that gives us the value of mu. So from what we've done, we have our mu to be 2, and then our x. Once again, this is a more than question. So since we are to find the probability that x is either 3, 4, 5, and so on and so forth, we'll rather find the opposite of this event, and then we subtract from 1. So x is 3, 4, 5, and so on. But the opposite of this event, if it's not more than If x is not more than 2, then x should be 2 or less. That's the opposite. So if the event says more than 2, then its opposite is 2 or less. So if its opposite is 2 or less, we now have our x to be 0, 1, and 2. So now let's quickly look at x equals 0, 1, and 2. So the formula for Poisson, once again, is giving us our mu exponent x multiplied by our constant exponent minus mu all over our x factorial. So probability of x being 0, 1, and 2 equals, we take the first, we have our mu, which is 2 exponential x, 0, multiplied by our constant exponent minus mu all over x factorial, x in this case is 0, plus we take the second, our mu once again is 2 exponent, our x value is 1, multiplied by our constant exponent minus mu all over our x, which in this case is 1 factorial. Then the last one, we have our mu again, which is 2, our exponent x, which in this case is 2, multiplied by our constant exponent minus mu all over our x, which is 2 factorial. Let's add these three events and see what we have. Once again, we have x equals 0.1, we have 0.1353 for x equals 0, and then for x equals 1. We have 0.2707, and then for x equals 2, we have 0.2707. So we have 0.6767 for the 3. Now, this is the sum of these three events. That's the opposite. We'll now subtract this value from 1 to give us the probability that out of 2,000 individuals, more than 2 individuals will suffer an adverse reaction. So we have 1 minus 0.6767, which gives us 0.3233. So this is our final answer for this particular question. So let's take note of Poisson questions. Whenever we have Poisson questions and then we are solving, let's try to fish out whether there has been a change of interval or whether the question is demanding for a more than or a less than, at least or at most. Let's try to identify if we have our mean or average. if not our standard deviation or variance. And then after writing the parameters, we know what step to take next. This will be the end of our discussion for today. Thank you for participating. Then follow this channel, Manual Statistics Arena, for more videos on statistical subjects, and don't forget to subscribe. Thank you.